Hello students, welcome back. We are continuing with the Geotechnical Engineering video lectures organized by AKTU. So, we have completed our index properties, which was the second unit. Okay, now we will carry on with the compaction of the soil. It can be taken as the third unit. Okay, so today we will be discussing about the compaction of soil. Okay, so the main our agenda today will be to elaborate the concepts of compaction of the soil, okay, through different graphs and all. Okay, we will understand how the compaction takes place in the ground. Okay, so let us move forward. Compaction of soil. Compaction of soil is the pressing of soil particles close to each other by mechanical method. Okay, so what is this? What is mechanical method? Actually, if you remember the if sometimes you have perhaps seen also in the ground, if it is compaction is to be done, then a rammer or a heavy object is continuously pressed on this, means it is lifted then pressed. Okay, so cyclic order or cyclic movement is carried out on the place where the compaction is to be done. What happens? So, this is the mechanical method. Okay, others there are many different methods, we will be discussing them later on, but for the time being you have to understand this, that when the rammer falls onto the ground or on the soil, then air voids are removed from this. Okay, air voids are expelled out, hence getting the particles closer together. Okay, getting the particles closer together, hence the compaction is caused. Air during compaction of soil is expelled from the void space in the soil mass, and therefore, the mass density is increased. Okay. What does this mean? Means once you compact the soil, obviously the density of the soil will increase, because now in the same volume V, okay, we have, if we had 100 particles, okay, 100 particles before the compaction, then in the same volume V, after the compaction, due to the expulsion of air and coming of the particles closer together, it may be 150 particles. Okay. So, what does this mean? This means that the density has increased. Compaction of the soil is done to improve the engineering properties such as density. Okay. Compaction of the soil is required for the construction of earth, dams, canal, embankments, highways, runways, etc. Actually, those places which will be having a higher load, okay, those places or areas where a high load will fall, okay, onto the ground, we have to first of all compact them, so that what will be caused, otherwise the failure of the soil may be caused. Okay, due to high load, the soil underneath it may get failed, okay, due to shear or settlement may be caused. So, to avoid that part, we first of all compact the soil, make the soil dense enough to carry out that load. Okay. Methods of testing the compaction of soil. First method is standard Proctor's test. Okay. To assess the amount of compaction of the soil, water content required in the field, compaction tests are done on the same soil in the laboratory. The test provides a relationship between the water content and dry density. Okay. The water content at which the maximum dry density is attained is obtained from the relationship provided by the test. Proctor used a standard mold of 4 inches internal diameter and effective height of 4.6 inches with 150 cubic foot of the capacity, but generally this is not used in our country. Okay, we don't use this Proctor standard inches and all. We will be using, I will show you in the later part. The mold had the detachable base plate and removable collar of 2 inches height at its top. The soil compacted in the mold in 3 layers, each layer have 25 blows. Okay, 5.5 pound rammer is used to blow it or to compact it with 12 inches height of fall. Okay, actually this test, this part is the first, this was the standard Proctor test, which actually was the first test to carry out the compaction, okay, in the ground or in the field. So, our method or IS compaction method or standard compaction which we use in our country is actually derived from the same process. We nearly have the same procedure, and just we have some variations in the weights and all. Okay, so we will be incorporating them, and we will see how in our country the process of compaction or Proctor test is carried out. Okay, so according to IS 2720 part 7, okay, this is where the compaction tests are included. Recommends essentially the same specification as in standard Proctor test, some minor modification. Okay, you have modification in the last one. How? The mold recommended is 100 mm diameter, okay, 127.3 height and 1000 ml capacity, the mold in which the compaction is to be carried out. Okay. The rammer is 2.6 kg, okay, and drop height is 310 mm, means 31 centimeter, means it has to go up for 31 mm. Okay, this is the rammer if, and this is the ground, then it has to go 31 centimeter above the ground, then it has to fall, again it has to go 31 centimeter, then it has to fall. Okay, and it is having the 50 mm diameter. Okay, this is 50 mm. Okay, the mold is fixed to the detachable base plate, the collar is 60 millimeter high. Beside this, remember that the compaction is done in 3 layers, 1, 2 and 3. Okay, the compaction will be done in 3 layers, and each layer is to be having this blow by the rammer 25 number of blows for each, for this, then again 25 for this, then again 25 for this, so that proper compaction is ensured. Okay. The procedure for the Proctor's test, let us see. About 3 kg of air dried soil is taken for the test. It is mixed with 8% of water content and filled in the mold in 3 layers, giving 25 blows each layer. Okay, just I told you 25 number of blows should be given to each layer, for this, then this, then this. The volume of the mold and the mass of the compacted soil is taken. The bulk density is calculated from the observation. A representative sample is placed in the oven to determine the water content. The dry density is found out from the bulk density and water content. Okay, means the same formula which you know already. Gamma D is gamma B upon 1 plus W. Okay, this is used. W is found out and this is found out, hence we can get this one. Okay. Then the test is repeated, increasing the water content. First we start with 8, then we can go further, increase the water content and do the compaction test, so that we can get a curve between, this is the dry density, okay, this is the dry density and this is water content. Okay, this type of curve will be obtained. Okay, we will be seeing that. Presentation of results of Proctor test. Okay, how is generally the result of Proctor test represented? Okay, that is done by compaction curve, the curve which I just showed you, something like this. Okay, a compaction curve is plotted between the water content as abscissa and the corresponding dry density as ordinate. Means here it will be water content, here it will be dry density. Remember, dry density, water content and dry density. Okay, it is observed that dry density initially increases with an increase in the water content till the maximum dry density, means as I have shown you roughly. First of all, with the increase in the water content, see this is increasing. Okay, dry density is increasing up to a maximum level. With further increase in the water content, dry density decreases. This you can see, this is now decreasing. We have increased further, now it is decreasing. The water content corresponding to maximum dry density is known as optimum moisture content or optimum water content. Okay, OMC or OWC. This, okay, corresponding to this, the water content which we will be getting here, this is known as OMC or OWC. Okay. At a water content more than the optimum, the additional water reduces the dry density as it occupies the space that might have been occupied by the solid particles. What happens? Why this decreases? Actually, what happens? First of all, you had soil particles, okay, and water in between them in a limited amount. Now, when you keep on increasing the water content of the soil, what will it do? It will replace, okay, it will replace out the different soil particles out of the whole volume. It will increase the volume as well and replace out the soil particles, due to which what will happen? You know that the density of soil particles is higher than the density of water. Okay, so water is having low density. Now, if water starts to nearly replace all the soil particles in the whole volume, then what will happen? Obviously, the density of whole we can say the phenomena or the density of whole body will obviously decrease, due to which we get the downfall curve. Okay. So, this was the concept. Then For a given water content, theoretical maximum density is obtained corresponding to the condition when there is no air. Okay, maximum density is obtained when there is no air void, means it's fully saturated. Okay, 100% saturation. The theoretical maximum density is known as saturation dry density. The line indicates theoretical maximum density can be plotted along the curve. It is known as zero air void line. I will show you what is it talking about. Now, in this diagram, if you see, this is the curve. Okay, this is the curve, and here you can see it is a line. This is the zero air void. I am sorry, this is zero air void line. Okay, this is the zero air void line. And what is this? This is the general compaction curve which we were talking about. This is the compaction curve. Okay, this is the compaction curve. This is the ZAV line. This is also called as ZAV line. Remember, this zero air void line is always same or equal to the 100% saturation line. 100% saturation line. Okay, this is always equal to 100% saturation line. This one, but remember, it doesn't mean that if there is a zero air void line is equal to 100, then it doesn't mean that 5% air void line. Okay, 5% air void line is never equal to 95% saturation line. Okay, only this is equal, only these are equal. Okay, and here what we see, this is the OMC, here maximum, sorry, this is the maximum. So, here this is the OMC. Okay, and this is called MDD in short. MDD means maximum dry density. Okay, this is maximum dry density, in short MDD, means highest density which could be obtained at that moisture content. After that, the density will start falling out. Okay, so this was the explanation for this curve. This is dry density, here you have water content, this is the maximum dry density, and this is OMC, optimum moisture content. Okay, now what we do in the general procedure or the general lab, we carry out this experiment for different water contents, so that the plots or the points can be obtained in a sufficient number, so that this plot can be made smooth. Okay, so we carry out with a number of water content, so that different dry density can be obtained. We can obtain a number of dry densities. Okay, then we can plot it and find out the maximum dry density. Okay, let's move forward. Factors affecting the compaction of soil. What factors actually affect the compaction of a soil? Okay, mainly water content, amount of compaction, type of soil, and methods of soil compaction. So, let us see one by one. Effect of water content on the compaction of soil. At low water content, the soil is stiff and offers more resistance to the compaction. As the water content is increased, the soil particles get lubricated. Okay, what does this mean? First of all, the soil particles are without any water or without any lubrication. Okay, only they are net, only the soil particles are there. So, due to this, what happens, there is a high resistance. If there is a flock, they will resist more. Okay, they will resist more to the compaction process. Okay, now once you start increasing the water content, what will happen, they will be filled with water. Okay, they will be filled with water everywhere. Due to this, what will happen, they will get dispersed. Okay, they will get dispersed, something like this. Now once they get dispersed, what will be happening, the compaction process gets easier, or more compaction can be carried out. Okay, the soil mass becomes more workable and the particles have closer packing. The dry density of the soil increases with the increase in the water content till the optimum moisture content, as just you saw in the graph, something like this. Okay, dry density keeps up to OMC, it keeps on increasing. With further increase in the water content, the air void do not decrease, but the total voids increase and the dry density decreases. This is the next reason, but the main reason you can remember will be that the soil particles get replaced. Okay, soil particles gets replaced by water, due to which this downfall occurs. Thus, the highest dry density is achieved up to the OMC or OWC due to forcing air voids out from the soil voids. After OMC or OWC is reached, it becomes more difficult to force air out and to further reduce their air voids. Okay. You know that a compaction, remember the compaction is the process of expelling of air out of voids. Okay. This is the process of compaction. Okay. Now, amount of compaction, which is the second factor. What we have written here, the compaction of the soil increases with the increase in the amount of compactive effort. Okay. With increase in the compactive effort, the optimum moisture content required for the compaction also decreases. Means, if you increase the compactive effort, first of all, let us say you are using a 10 kg rammer, later on you increase it to 20 kg rammer. Okay. From 10 you directly increase it to 20 kg. What will happen? Okay. Due to this, the OMC, first of all, if it was this, then it will become this, the OMC will decrease. Okay. I am sorry, let me make it. What will happen if you have first of all like this, then later on it will become like this, means OMC will decrease. Okay. First of all it was here, later on it will be here. Okay. It will be same, but this will decrease this much if we if we increase the compactive effort, optimum moisture content will decrease. At water content less than the OMC or optimum, the effect of increased compaction is more predominant. Okay. It may be mentioned that maximum dry density does not go on increasing with the increase in the compactive effort. For a certain increase in the compactive effort, the increase in the dry density becomes smaller and smaller. Okay. Finally, a stage comes beyond which there is no further increase in the dry density. Okay. Actually, what happens, if we see the diagram, we will find that the diagram, final diagram, this for only OMC I was talking. Okay. It will be something like this. Okay. It will like this. Okay. You can see it is decreasing, OMC is increasing. Okay. From this diagram you must understand that this graph, the first graph is for the highest compactive effort, then the second graph, then the third one. Okay. 1, 2, 3, if I number them, then according to compactive effort this is the highest, then this, then this. Okay. And according to dry density, gamma d, according to gamma d, what will happen? Again one is highest, then second, then third. But for moisture content, optimum moisture content, if we see what will happen, third is the highest, then 2, then only 1. Okay. You can note it down. Then the line of optimums which joins the peaks of the compaction curve of different compactive effort follows the general trend of zero air void line. This is the line of optimum. Okay. It is joining all OMC and MDD, means highest point. This is known as the line of optimum. This one, line of optimums. Okay. This is the line of optimum. Okay, I can again make it here something like this. If this and this and this, then this is the line of optimum. Okay. Now let us move forward. Type of soil. How does this depend, or how does this affect the compaction of the soil? The compaction of soil depends upon the type of soil. The maximum dry density and the optimum moisture content for different soil are shown in the figure. In general, the coarse grain soil can be compacted to a higher dry density than the fine grain soil. Okay. What happens? Let me show you the figure first of all. This is the diagram. Okay. If you see, you can see that this is the sand. This is for well graded sand, and this is for clay. Okay. High plasticity clay. If you can see how high it has how very the highest gamma d, but in case of this it has very low gamma d. Okay. What does this signify? If plasticity increases, okay, increase increase in plasticity, what will this do? Decrease the gamma d max or maximum dry density. Okay, but what it will do? Increase the optimum moisture content. Okay. So this was one this was the one drawback, you can say the conclusion which we can draw from this graph. You can see, okay, this is for sand, then this is for silt, then this is for clay, this is of low plasticity, this is of high plasticity, you have been written here. So further let us move on. What was written? With the addition of even a small quantity of fines to the coarse grain, the soil attains a much higher dry density for the same compactive effort. Type of soil, you can understand that if clay is there, it will be having low gamma d, okay, for clay. If there is coarse grain such as sand, if it is compacted in a well manner, then it will be having a high gamma d or maximum dry density. If quantity of the fines is increased to a value more than that required to fill the voids of the coarse grain, the maximum dry density decreases. A well graded sand attains a much higher dry density than a poorly graded sand soil, as I showed you in the diagram. Cohesive soils have high air voids. These soils attain a relatively lower maximum dry density. Okay, you mean cohesive soil, obviously I told you that it will have lesser and this will have higher. Besides this, if you have some larger, you can say gravels type, and if you use fines, okay, to fill their voids, okay, means you use the mixture, you use a mixture or a proper gradation, or this can also be called as well graded, then this will have highest maximum dry density. Okay, so this was it about this. Then you already understood this one. Now method of soil compaction. Method of soil compaction, sometimes you use rollers, sometimes rammers, okay, sometimes you use rollers, sometimes you use rammers, sometimes you use kneading action, okay, sometimes you use kneading action, sometimes you do what? Impact action, okay, impact action. So accordingly they have different roles. The dry density achieved depends not only upon the amount of compactive effort, but also on the method of compaction. For the same amount of compactive effort, dry density will depend upon whether the method of compaction utilizes kneading action, dynamic action, static action. Okay. Different methods of compaction curve will give their own compaction effort, compaction curves. Consequently, the lines of optimums are also different. Okay. What happens if there is suppose the cohesive soil, then it is best compacted by kneading action. Okay. Again, for sand either you have to use the dynamic action or flotation is also done sometime, okay, to compact it, flotation. Okay. So likewise there are different types of compaction method, accordingly we will be having the dry density of them. We will discuss about these later on also. So this much is for the time being. So you can consult what is the compaction of soil and all, just go through the questions. Okay, this will help you out to revise or groom your concepts. Later on we will be again consulting about the different other remaining concepts of the compaction of soil, and also deal with some numericals based on them. Okay, so keep watching the videos. Thank you.